Hello, today we're going to finish up chapter 4.2 notes. We will be talking about the quantum numbers of an electron. So there are 4 quantum numbers, starting with the principal quantum number, lowercase n, and it tells us the main energy level of that electron. These are also called shells of the electrons. So we have n equals 1, that would be energy level 1, n equals 2, energy level 2, and 3, and so on. The total number of electrons in a given shell or energy level is 2 times the energy level squared. So for example, how many electrons in energy level 2? So we would take 2 times n, which is 2 for energy level 2, squared. 2, whoops, not to the n, that's squared. So we would have 2 times 2 squared. This is 4 times 2 would be 8 electrons in that second energy level. So remember we said it goes 2 fit in this energy level, followed by 8, and then energy level 3 would be 3 squared times 2, which is 9 times 2, which is 18. That's a 2. 18 electrons fit in the third energy level. And so in this third energy level, we could hold up to 18. How about the fourth energy level? 4 squared is 16 times 2. That's 32. And what about the fifth energy level? Good. 5 squared is 25 times 2 is 50. So we don't need that many energy levels to fit all of the electrons in. It only goes up to the 7th energy level for the periodic table. Okay, so that's energy level, and it tells us how far away from the nucleus you are. So we have all these different energy levels telling you how far away from this nucleus you are. The angular momentum quantum number tells us the shape of the orbital. So there are different shapes that the electrons can be found in. They are S, P, D, and F. So for the S shape, it's just a sphere. Okay, so we have the spherical shape. It's not 2-dimensional, so this is my best 3-dimensional sphere here. And so any of the s orbitals are going to be a spherical shape. For the p orbitals are going to be 2 lobes, kind of looks like a figure 8, okay, like this. So this is a p orbital, and each energy level has 3 of them. We call them px, py, and pz. We'll get to that in a second, but they look like this. Okay, then we have the d orbitals. The d orbitals have 4 lobes, and they look like, oops, that's not the best drawing of it. They're symmetrical. Okay, but you guys get the idea. So here is my d orbital. Kind of looks like a 4-leaf clover now. Okay, there are 4 lobes in the d orbital. I'm not going to try to draw F. You can look in your book. Actually, I will try, but it's not going to be pretty. They have about 8 lobes. So you have like 4 pointing up and 4 pointing down. And it looks very little like what I just drew. So look in your textbook or look online for the shape of the F orbitals. Okay, how many orbital shapes are in energy level 2 or 4? The different shapes correspond to the energy level. So what this is saying is, for example, in energy level 2, you have 2 shapes. 2 shapes in n equals 2. That's energy level 2. Okay, so in energy level 4, there are 4 shapes in energy level 4. Every energy level has that many number of shapes. Energy level 5 has 5 different shapes. All right. The magnetic quantum number tells us the orientation of the orbital around the nucleus. And we don't need to worry ourselves about this negative L to positive L business. What we need to know is an s orbital can only have one orientation. So since it's a sphere, no matter how I rotate the sphere around the nucleus, it's always going to look exactly the same. So S has one possible orientation. For the p orbitals, we have 3. We have px, okay, which looks like that, px. We have py, which looks something like this. Okay, it's a little more complicated than this, but we're going to simplify it. Okay, so filling that in since I messed up a little bit. Py, and then pz is the third orientation, and we can think of that one as coming out towards us, and then the dotted line is showing that it's going back into the board. Okay, so there are 3 orientations for the P. I'm going to put a big 3 here. There's 3 orientations for P. D has 5 different orientations, so I'm not going to draw them. I'm just going to write. Here we have S, and then we had P, right? P had 3 different orientations. For D, the d orbitals have 5 orientations that you can see in your book. And lastly, the f orbitals, there are 7 different shaped orientations, and you can look at them in your book. Okay, so these are odd numbers. It's pretty easy to remember. 1, 3, 5, 7. That's how many orientations are in these different shapes. And last but not least, we have the spin quantum number. This can be very complicated because it's not an actual spin, it's some quantum mechanical property of the electron. All you need to know is that you have a spin up, which is plus 1/2, and a spin down, which is minus 1/2. So there are 2 spins, 2 possible spin numbers, okay? And they are up, which is plus 1/2, and down, which is minus 1/2. Okay, so 2 possible spins. How many electrons can exist in the 2p orbitals? So this is a tricky question. We had px, py, and then pz comes out towards us and goes back here. Every orientation, so px can hold 2 electrons. One is spin up and one is spin down. Py holds 2 electrons, one spin up and one spin down, and pz also holds 2. So the total for all of these p orbitals combined is 6 electrons. It doesn't matter what energy level the p orbitals are from, so 2p or 3p or 5p, any of the p orbitals will always hold 6 electrons. The s orbitals, s only has 1 orientation, and that 1 orientation can hold 2 electrons. So S, there's only 1 orientation, it holds 2 electrons every time. F, since it has 7 different orientations to it, each orientation can hold 2 electrons, so the total number of electrons for any F orbitals is going to be 14. Okay, and lastly, I did these out of order on purpose to kind of make you think. The d orbitals have 5 orientations, and every orientation holds 2 electrons. So the total number of any d orbitals is going to be 10 electrons. Okay, let's add that to our chart up here. This holds 2 electrons. This one holds 6 electrons. The d orbitals hold, show you which letter. The d orbitals hold 10 electrons. And then lastly, F holds 14 electrons. So you're going to want to remember how many electrons fit in each of these shaped orbitals. Okay. And here's just a quick recap of our 4 quantum numbers. N is the energy level, which tells us how far from the nucleus we are. So it's just telling us which energy level it's in. L is the shape. Okay, so we don't have to memorize the letter L, but the shape, we have S, P, D, and then F is strange looking. The orientation is the 3rd energy level. There's 1 orientation for S, 3 orientations for P, 5 orientations for the d orbitals, and 7 orientations for the f orbitals. And then lastly, we have the spin. There's spin up and spin down. Okay, that's it for the quantum numbers. We're going to use those next section, and I will see you then.